Okay, welcome back Physics 30s to our next lesson. This is 7.1 and today we're going to be talking about nuclear physics. Okay, so in the last unit we looked a lot at the nature of the electrons in the atom, but in this chapter we're going to start looking at the nature of the nucleus. So the nucleus is the center of the atom and it is much heavier than the electrons. It's made up of protons and neutrons. I have this diagram and let's say that the blue circles there are protons and the white ones are neutrons. They're both approximately the same size, which is about 2,000 times heavier than an electron. So this makes up the large majority of the mass of the atom. And anything that's in the nucleus, so these protons and neutrons, are called nucleons. And we'll refer to that because they are quite similar. And when we're talking about total mass, it'll be the mass of the nucleons. Now this diagram is typical to what we would draw an atom like before we started talking about the weird nature of electrons. But we're going to go back to this diagram. So it's got the nucleus in the center and then these rings of electrons around the outside. The electrons and the protons are going to determine most of its characteristics because the electrons are going to be involved in how it interacts with other atoms and whether it's going to share electrons or transfer them in bonds. And the protons, it has to have the same number of protons and electrons in an atom to be overall neutral. Now this diagram here has 6 protons and 6 electrons. What that means is it's going to be a carbon atom because what element it is determined by how many protons, and 6 protons means it's going to be carbon, and because this is a neutral atom it's got 6 electrons. Now in this case we have 6 neutrons as well, and this is what we most commonly find where it has a mass of 12 because we have 12 nucleons. However, the nucleus doesn't have to just have 6 protons, it could have 2 more, making it so there's 8 neutrons and 14 nucleons. These are called isotopes, and an isotope is a variation of an element with a different number of neutrons. So for example, here we have carbon-12 and carbon-14. Carbon-12 has 12 nucleons, carbon-14 has 14 nucleons, like we saw with 2 extra neutrons. Protons have to stay the same, because remember, that's what defines it as carbon. Since this is just the nucleus that's changing, the changing nucleus in an isotope is called a nuclide, which is a variation of the nucleus with different number of neutrons. Just kind of saying that the electrons are staying the same, it's just a change in the nucleus. Now how we're going to represent what's going on in the nucleus is in nuclear notation. So we have here C, 12, and 6. What this represents is the 12 represents the number of nucleons, the total amount of things in the nucleus, protons and neutrons. Then the lower number of 6 just means the number of protons. This is also communicated by just being carbon. We know carbon is defined by 6 protons, but this is how we write nuclear notation. From those two numbers, we can determine the amount of neutrons. We say, okay, there's 12 things in there, minus 6 protons, there is 6 neutrons. This is how we would write carbon-14, again, still 6 protons, still carbon, but now 14 minus 6 gives us 8 neutrons. You could also get a question like this, which says which element has this isotope and how many neutrons are there. To determine the element, look at this bottom number here, 12, that tells you the number of protons. So we look up that atomic number on the periodic table, and it turns out to be magnesium. So that's the first question. And then to determine the number of neutrons, again, we just take 26 minus 12, and we should get 14 neutrons. Sometimes isotopes are written like this, uranium-235. The 235 means the amount of nucleons, and then you might be asked to determine the number of protons and neutrons in that. Let's start by finding uranium on the periodic table. And it says normally it has a mass of 238. So this is a variation of the normal one we'd find on the periodic table. But what's going to stay the same is this number of 92 protons. Okay, so we can figure that out first. I'm going to write this. So I know there's 92 protons, it's uranium, and 235 is the amount of nucleons from the question up here. So now I know the number of protons, again from the periodic table. To find neutrons, I just subtract 235 minus 92, and I get 143 neutrons. Okay, so I know that was pretty short. That's just our introduction into looking at the nucleus and looking at isotopes and nuclear notation. I hope that made some sense for you. Give those practice questions a try, and I will see you in the next video.